Now let's talk about local file disclosure. This vulnerability would allow an attacker to practically fetch any local files on the system depending on how the application is implemented. The files that we can fetch with this vulnerability strictly depends on how the application is written, but in some cases we can either access user files on the web server or actually read files that are local to that box. In other words, this vulnerability would allow us to read practically any files that's hosted on this machine, whether it belongs to the users or it's a default file on the web server. Now let's look at an example. In this example, we can see that mybankingsite.com has an endpoint called view file, and this endpoint has a parameter called image, where it fetches a user's image, like their avatar, using the format above. Now, if we change that path from image my avatar to //////Etsy password, it would actually pull up the Etsy password on the local machine and show it to us. As you can see here, we're fetching an Etsy password, and the result is going to show us the content of that file. And again, if you're not familiar with Linux file systems, this is a default file. It gives you information on every user that's on this box. Now let's go back to our example and look at what this means. As you can see here, the application is saying, hey, I want you to fetch for images and get myavatar.jpg. This myavatar could be any arbitrary file. So again, the application is saying within wherever I'm at, so wherever my script is running, whatever this file is hosted on the machine, I want you to fetch the folder images and the file myavatar.jpg. Again, myavatar could be any name or any file that belongs to a user. It could be our file that we want to fetch. It could be an invoice, whatever it is. The path, now it's assumed that we are in home, bank site, ////images. This is where the application is hosting all these images, and every website that we go across has some sort of a similar path. So in other words, it's not always /home/banksite images. That could change depending on how the site is configured. By doing a // in a Linux environment, we're actually telling the website to traverse out of each directory and go back one. So when we do the first // it takes us out of the images folder. When we do another one, it goes back from the // and then the third one goes out of bank site, and the fourth one puts us in the root directory, which is just a /. If you're not familiar with how the Linux path system works, I highly recommend either installing an operating system like Ubuntu or Kali and getting familiar with it, or at least looking into how files are stored and what are some of the default files on a Linux box. So let's piece this back together. When we give the application our first set of // it's going to take it and put it in front of the actual path that we're looking for. So again, this is where the images are stored. It's going to say fetch // and that would translate it to home backside // which means that we have came out of this images folder. Now we're going to do the same thing at another trailing // and since there's two of them that we're going out of, it's going to take out images in // and translate it into home bank site. If we do a third one, so on, it's going to do 1, 2, and 3, which is going to become just home. And then if we do a fourth one, 1, 2, 3, and 4, it's going to just go to a /, which is the root directory. And once you give it our Etsy password, it's going to just translate that to the Etsy password where the file is stored, and it's going to display its content. In some cases, you may actually not need to do a // but it's very helpful to do it, especially in the case of having the path for each folder being hard-coded into the code. So in this example, if I just say Etsy password, it's going to come back and say, hey, I can't locate Etsy password within images, and I can't show you any files. This may not happen in every web application because sometimes the errors may be hidden, but in this case, the application is coming back and it says, hey, Etsy password doesn't exist within the folders that I'm working with. So this is a perfect time to actually go ahead and use our trick, escape out of the current directories that we're in, and fetch for that file. So for example, if we go to download our transaction from this bank site, it's going to actually spit out a username.csv file, but as you can see in the request, we don't see the extension of the file that we're downloading. This could be because the application has it hard-coded, so we may have to find a way around it. For this example, we can either use a null byte. I'll make sure to have this included in the resources. And sometimes we can actually use a question mark depending on how the application is coded, but you have to kind of spend some time and understand how each request is being sent and what kind of a filtering you're dealing with. So again, this doesn't have to always be a null byte. It could also be by adding an invalid character or a question mark, but it just comes down to how the application works and what are the limitations that you're going against. While a null byte injection or a question mark may help us get rid of the remainder of the string, That's not always the case. We may actually have to deal with other limitations, or in some cases there may be a filtering in place where the dot// may get filtered or taken out of our request. So let's talk about URL encoding first. A URL encoded string is universally accepted by both the web server and the web browser. So in other words, if we provide an application a URL encoded string, it would understand how to deal with it and what to translate it to. For example, a dot becomes a %2e and a slash becomes a %2f. And the combination of dot// becomes %2e, %2e, %2f. So now imagine if you give an application a dot// and the application converts the dot// into an empty string. So in other words, when we provide an application a dot// it may actually take it and convert it to an empty string. So in other words, it's going to say, if you see a dot// as a string, ignore it and replace it with nothing. So in this case, it means we can't go back out of our directory, and it doesn't help us to traverse out in order to get a local file disclosure. But since the application is looking for a set of strings in a particular order, we can actually mess with it a little bit until we understand how it works. In this case, the application looks for 2 dots and a slash, and only that string, and it replaces it with nothing. So if we add a dot in the beginning and a dot/ at the end of our dot/, it will take down the middle part and convert it to a dot// at the end. We can also just add 2 additional dots in the beginning and a slash at the end, and the application is going to look at it and only match the dot// that it's expecting, replace it with nothing, but at the end it would convert our entire string into a dot// and allow us to exploit our vulnerability. Again, this is all about creativity and understanding how the filtering system works, but I've seen this in a bunch of applications in the past, and it's allowed me to exploit them further.